Hola, 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 hola. ¿Cómo están mis estimados aprendices? Espero que estén despiertos. Espero que estén todo bien, todo azul. Speaker view. All right. Play my video and let me change the position of the camera. All right. Today we're going to continue. Well, actually, we're going to start the solving the physics bimestral exam. All right. If you have doubts or questions, don't hesitate to let me know. But guys, um, let me tell you one thing before to start the solving exam. I think I was warning you last year when you were at 10th grade. I think if I remember the first time or the second time when you upload the one homework geometry, if I remember, and I said, guys, do not sending process or problems copy directly of the solutionary book. I told you already since the last year. And actually, the rest of the year you're doing sometimes yes, sometimes no, sometimes copy one problem. But in this bimestral exam, the most of you, I'm using the solutionary textbook. And this is not in any way process acceptable to being in part of the part of the class. So the last time, this last time I'm penalizing you, only giving you 2, 3, or 4 points. Okay. The next time you're going to use using solutionary process, I give you my word. And I swear to God, you're going to get 0 if you're using solutionary process next time. In the bimester exam, if you have doubts, questions, you're not pretty sure about the one singular formula in the exam, please ask me. There's no problem, no inconvenience with that one. But uh, in one case, but if you don't ask me and you're using solutionary process, we're going to have serious problems. Okay. So we're just going to discuss the bimestral exam. And please, if you have doubts or questions, don't hesitate to let me know. All right. Just hold on a second. Okay. Okay. So let's begin. In the first word, ouch. In the first problem says, the problem number 1. The equation of motion of a particle, the equation of motion of a particle, in vertical simple harmonic motion, in vertical simple harmonic motion, it's given by, is given by, okay, by what? Y equals 75 centimeters sine is 0.60 radians per second t. Okay. So the question are, what are the particles displacement what is displacement, velocity, and acceleration at, in this case, t equals 7.5 seconds. Well, in this, the first problem, there's no big deal or big situation. How are we going to solve that thing? Because the only thing that you must do is uh, use that equation and substitute by 7.5 and make sure your calculator must be set up in radius mode. For example, if you really want to know what will be the displacement, we must multiply 75 centimeters multiplied by sine brackets 0.60 radius per second multiplied by 7.5 seconds. Okay, so the displacement, the vertical displacement in this situation will be given by negative 73.31 centimeters. Some of you gave me the answer in meters, no problem, but remember this displacement that's supposed to give us a negative answer. Now, the velocity. The velocity, my dear students, remember the velocity is the product between amplitude times velocity times cosine of the angle. So if you multiply 75 times 0.6, remember that will be equal to 45 centimeters per second cosine, and we got the same function. I mean 0.6 radians per second multiplying by 7.5 seconds. So the velocity evaluated 7.5 seconds, okay, that will be equal to negative 9.49 centimeters per second. This is going to be the magnitude of the velocity. And the magnitude of the acceleration, ADT, or the acceleration evaluated in 7.5 seconds, remember, is the product between the amplitude, the omega, or the angular velocity, the second power, sine of that situation, okay? Well, actually, it will be negative, the amplitude. So multiplying that situation, we got negative 27 centimeters per second square, multiplying again, or sine of what? 0.6 radians per second multiplied by 7.5 seconds. Well, actually, those equations I given you since the beginning of the unit. So this angular acceleration will be given by 26.39 centimeters per second square. And this is going to be the solution set at least for the first problem. Only apply the formulas and substitute. No more, no less than that. Okay, that was the problem number one.
Mr.
Uh-huh.
One question. The formula for velocity doesn't have a negative sign like the one in acceleration.
Remember, this is a vertical, in the problem says, in vertical simple monical motion. In vertical, we start from sine in the displacement and cosine with the velocity. And if I set horizontal displacement, okay, in that case, the velocity, we have a negative the formula because we're talking about displacement. Okay,
Okay.
remember, the problem says vertical, and that's why That's the reason why we started from sine, no cosine. Okay. In the second problem, we have a block of 0.35 kilograms, 0.35 kilograms, moving vertically upward, vertically upward, collides with the light vertical string with a vertical light spring, light spring, and compresses it and compresses it 4.5 centimeters, 4.5 centimeters before coming to rest. Before coming to rest. The question is, I don't know, before coming to, if the spring constant is 100 newtons per meter, the question is, what is the initial speed? What is the initial speed? What is the initial speed of the block? Okay, if we analyze the situation in the perspective, instead of moving that one in a vertical perspective, we are moving in the horizontal perspective. This block is going to move some kind of velocity, and it's going to compress this line spring, okay, until it reaches the final velocity of 0 units. Okay, this is going to be one single picture of the problem, just like a shortcut. So if you want to apply the conservation energy, remember the final rotational potential energy plus the, sorry, the gravitational potential at the beginning plus the elastic potential energy plus the initial kinetic energy, that will be equal to the final potential energy plus the final elastic potential energy plus the final kinetic energy plus the quantity energy losses or loses by the possible presence of the friction force. Okay, because the problem, there is no friction force in the problem. All right, we're going to discard this situation because the line and the spring and the block moves in the same line. There's no height, so at the beginning and the end, the gravitational potential energy will be canceled. The elastic potential energy, there is no elastic potential in the beginning because there is no compression in the spring. But at the end, there's going to be a compression. Um, Obviously, the block moves some kind of initial velocity until it's coming to rest. For that reason, there's not going to be final kinetic energy. For that reason, the initial kinetic energy that will be equal to the final elastic potential energy. Okay, so let's going to apply the formula. 1/2 mass velocity initial second power equals 1/2 kx squared. Because 1/2 is the same thing and we are looking for the initial velocity. So the initial velocity will be equal to kx squared over m, taking the square root. This is going to be the initial velocity. I mean, square root of what? 150 newtons per meters. The value from x is 0.045 meters at the second power divided by the mass of the block is 0.35 kilograms. So the initial velocity of the block in this case will be equal to 0.932 meters per second. This is going to be the answer, at least, of the problem number 2. No big deal, no big situation, okay? So the problem number 3. Guys, before to write the problem number 3, would you like to tell me what is the difference between 4.8 times 10 at the 4 power and 4.8 times 10 at the negative 4 power? Would you like to explain me what will be the difference between these two quantities?
Mm, 4.8 times 10 to the negative 4
Mhm.
is less than 1, and 4.8 times 10 to the 4 is like 48,000.
Yeah, or it's simply worse. Negative 4, the power negative 4 means we're going to have 4 zeros to the left side of the number. And the positive 4 means we got 4 zeros or 4 digits at the right side, okay? So that's why I'm asking for that situation. Well, let's just see what I'm talking about, because this is a controversial issues in the problem number 3. Eso pasa cuando chepeamos y no nos fijamos que chepeamos. Y me ponen por poner chicha, me salen con limonada y Mr. Button no cree en esos errores. Y si hay un error de esos, no lo perdona, porque no puede ser. No puedo pretender confundir 5 lempiras con $5. Usted no va a confundir 100 lempiras con $100. Jamás. Y ya verá por qué lo digo. Ay, guys. Bueno, problem number 3. Y por la cara que están haciendo, yo creo que no soy el único maestro que les está llamando la atención. Por lo mismo, creo. A sonar, claro, no lo estoy diciendo por todo, ¿verdad? Hablo en términos generales. No lo digo por alguien específico. A sonar generator on a submarine, on a submarine, of a submarine, produces ultrasonic waves. Ultrasonic waves. Ultrasonic waves at a frequency of 2.5 megahertz. 2.5 megahertz. The wavelength of the waves, the wavelength of the waves, in seawater is 4.8 times 10 at the negative 4 power meters. All right, 4.5 meters. Period. When the generator is directly downward, 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 an echo, an echo, 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 reflect, reflect from ocean floor. From ocean floor is received 12 seconds later. The question is, how deep is the ocean? Okay, this problem number 3 is so easier for us at the moment to discuss what we have to do because they're asking for what will be the depth of the ocean. Well, actually, the speed of the wave are traveling at constant speed. So the first thing that we must do is try to looking for what will be the speed of the sound. And there will be the product between alpha times the frequency, gamma times the frequency, sorry. The value from gamma is 4.8 times 10 at the negative 4 power meters. And the frequency 2.5 megahertz is another way of saying 2.5 times 10 at the 6 power hertz. And if you multiply those quantities, the answer will be 1,200 meters per second. Okay, excellent. But if you multiply 4.8 times 10 at the 4 power times 2.5 times 10 to the 6 power, in your best streams, we're going to obtain 1,200 meters per second. This is the reality. But that reason, if you made that kind of mistake, there's no mercy, but zero. There's no possibility you can obtain, and there's no possibility, could be one or two people, but around 17 people make the same mistake. I don't think so. I don't think so. So, but the problem asking for what will be the deep, the distance, velocity times the period of time. We know what is the velocity, 1,200 meters per second, but the period time, this is not going to be 12 seconds because 12 seconds is the reflection, is an echo. So the only thing that we must do is take the half value of the period of time, that will be 6 seconds. For that reason, the distance will be 7,200 meters, or if you wish, 7.2 kilometers. This is going to be that solution set, at least for the problem number 3. All right. Problem number 4. Problem number 4. La 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 la. Problem number 4. La 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 la. Okay. On a violin, I don't know if it's the right pronunciation, violin or violin. I think it's violin. On a violin. Okay. A correctly toned, correctly, a correctly tuned tuned A string has a frequency of has a frequency of 440 hertz. 440 hertz. Okay. All right. Period. If an string, even a string, sorry, produces produces mm, sound at 450 hertz, 450 hertz under a tension of 500 newtons. Chon, 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 what should be the tension? What should be the tension? What should be the tension to be produced? To be produced the correct frequency. Okay, all right. Let's analyze the situation. We can say, okay, the first frequency we have over here, frequency 1, 550 hertz. And the first tension or the force number 1, if you want to say that thing, could be 500 newtons. So the question is, what will be the new force to produce the right frequency? Well, we can say the frequency number 2, 440 hertz, and the new force that produces the right frequency. Or if you wish, you can call this one frequency 2, force 2, and you're looking for the force number 1. It doesn't matter. At the end, the result will be the same. But what will be the analyze of the situation? The analyze of this situation, my dear students, it doesn't matter what kind of string do we have. At the end, the linear density of the string will be the same. So if you remember what is the equation of the velocity of the sound depending from the string will be equal to square root of the force divided by mu, right? And if elevated second power, both sides of the equation, velocity second power will be equal to mu force divided by mu, okay? And if we divide mu, so we're going to establish the equation that mu will be equal to the division between the force divided by the velocity of the second power. This is why I'm doing this one, because it's the logical relationship, because we are looking for what will be the relationship to looking for the same string. So let's begin. The linear density of the string at the beginning will be the same linear string at the end, because we're talking about the same string. And because mu is equals to force 1 over velocity 1 second power equals force 2 over velocity 2 second power, We have a right relationship. Some of you guys created a strange relationship divided by the frequency over frequency equal force divided by force. At once, but how you conclude that situation? This is the best question I'm doing performing in my head. Because if you want equal something, the most logical sense to equal will be the linear density because we're talking about the same holy string, right? But we have a situation. We know one of these force, we don't know the value for the force number two, and we have no idea what are the velocity values. But by the other hand, the velocity can be calculated multiplying lambda times frequency, right? Yes or no? Of course it is. Now we can create that relationship. All right. So force one divided by lambda one second power, frequency one second power, and actually lambda will be the same because if we're talking about we're going to have the same linear density, is because we have the same wavelength. So the force 2 divided by lambda frequency 2 of the second power. Okay, and because lambda at the second power is the same lambda, the second power, it can perfectly cancel. And what we are looking for, according for this proportion, and looking for the force number 2. So for that reason, frequencies 2, the second power is multiplying, dividing, passes to multiply. And we have these beautiful proportions. I mean, we got frequency 2 over frequency 1 elevated the second power because both are elevated the second power, multiplying by the force 1. This is going to be equal the force number 2. That's to make sense. We've clarified the situation, right? So let's see what we got. What is the body of the frequency 2? 440. You don't need to include hertz because the hertz will be canceled. The frequency 1, 450. Elevated the second power and multiplying by multiplying by 500 newtons. 500 newtons. And this is going to be the new force. And the new force, my dear students, will be given by 478.02. 478.02 newtons. And this is going to be the new force or the right force that we're supposed to apply to produce the right frequency. Understood? Así es como se hace un reloj. No que de un solo guamellazo, que F1, F2, frecuencia 2 o frecuencia 1. O sea, ¿qué onda? ¿Cómo sacaron esa conclusión? No me anden chepeando, solucionarios. Bueno, muchachos, lo vamos a dejar hasta aquí. Día de mañana seguimos desarrollando este examen. Dios los bendiga, los guarde, los cuide. Bye bye. So long. Take care of yourself.